What's a progression? Same as sequence. A geometric sequence is a sequence of numbers where each term after the first is found by multiplying or dividing the previous one by a fixed non-zero number called the something something, where the abbreviation is R, not D anymore, R. Common ratio. Example 1, comma 2, comma. Now, up till 30 seconds ago, we would have put 3, then we would have put 4, then we would have put 5, because that was arithmetic. Now we need to think geometric. 1 times 2 gives us 2. So the next number times 2 would be? Times 2 would be? Times 2 would be? Dot, dot, dot. 32, 64, da, 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 da. So it's no longer good enough just to give 2 terms. With 2 terms, we don't have a clue what the sequence is. You need at least 3 terms to be able to figure out whether it's arithmetic or geometric. This makes the general form. Just follow me here for a second. It's a little bit of theory. I'm going to call T1 T1. Now, instead of calling the second team 2 just for a second, I'm going to call it T1 times R. Because that's how we get the second term. We take the first term, we times by R. How do we get the third term? Well, we take the second term and we times by R. So what's T1 times R times R? What's T1 times R times R? T1 R squared. And then to get the fourth term, we take the third term and times by R. So what's T1 times R squared times R? T1 R cubed. I sense you're getting the pattern. What would the next term be? T1 R to the fourth dot, dot, dot. What would Tn be? So it's going to have a T1 because they all have a T1. So the fifth term has an R to the 4. And the fourth term has an R to the 3. And the third term has an R to the 2. And the second term has an R to the 1. And although we don't see it, there's actually an R in the first term. It's R to the what? 0. And what's anything to the exponent of 0? Nothing. So the first term is R to the 0. The second term is R to the 1. The third term is R to the 2. The fourth term is R to the 3. The fifth term is R to the 4. What would the n term be? R to the n minus 1. I'm going to jump a little bit and come down to the formula that we're going to learn in a second. It comes just from that pattern. Tn is T1 times R to the n minus 1. Is it on your formula sheet? Prove it. Find it. Don't be lazy. Everybody turn and look because it's bringing your eye to where the formula is so that later on the test when you're panicky, you know where the formula is. Where is it on that formula sheet? I put it in the box. Remember, all the Unit 1 formulas are all together in a nice little box. Left brain can't help it. Let's back up some vocabulary. When R is greater than 1, the sequence is, so before with arithmetic we had increasing and decreasing. We're going to change up the vocabulary. When it's greater than 1, we call it diverging. Sequence is diverging. What that means is it's going away from 0. The numbers are getting bigger and bigger and bigger, away from 0. When, what's this notation? 0, less than R, less than 1. Remember, mathematicians, we don't like words, we like symbols. What does this less than R, less than mean? What English word is that saying? Between. So if you need to put that word, put it. It's just a fancy way of saying between. When R is between 0 and 1, so it means it's a fraction. The sequence is converging. Converging means the numbers are coming towards 0 or getting smaller. We're going to start with the exact same example that we did with arithmetic. We're going to decide, is it geometric, yes or no? Therefore, if it is it converging or diverging? And what's the value of R? Let's talk about how to find R. How did we find D? Took any term and subtracted the previous one. How do you think we're going to find r? Divide. So what was the notation we used for any term, just a general term? Tn. What notation did we use for the previous term, the one before? Tn minus 1. Again, that's just a fancy way of saying in English, take any term and divide by the previous term. Take any term and divide by the previous term. Take any term and divide by the previous term. Are you eating an avocado? That is kind of exciting. No one's ever eaten an avocado in here. It's kind of, I do too. That kind of made me happy. No, that's kind of exciting. Let's do the first one together, then you'll do B and C with a friend. How to decide if it's geometric. Same way with arithmetic, except we're going to divide or multiply. How do we go from 1 to 3? So now we check. 3 times 3? 9. Check. 9 times 3? Check. Therefore, the first answer is yes, it is arithmetic or geometric. Converging or diverging, are the numbers going away from 0 or are they coming down towards 0? It is diverging because the numbers are going away from 0. And r has to equal 3. That comes from 27 divided by 9, or 9 divided by 3, or 3 divided by 1. Turn and talk, do B and C. Letter B, yes or no? Diverging or converging? Because it's coming down towards 0. If it's converging, you already have a hint about r. What does r have to be? Has to be a fraction. Has to be a number less than 1. Take any number divided by the previous number. R equals? Oh, negative 2 is the trick. It is getting smaller, so it has to be negative a half. Negative a half.
So is that
0.5? Yeah, I'd accept that as long as it's negative. So we do negative 1 divided by 2, or 2 divided by negative 4, negative 4 divided by 8.
So
Negative 2 would be a diverging sequence, meaning it's getting bigger. Casey doesn't believe me. She's about to divide to make sure that it's 0.5. She really doesn't believe me. Like, we spent a whole year together last year, and she doesn't trust me. No, I kind of enjoy that she doesn't trust me, actually, because I make mistakes, too. Because I make mistakes, so I want people to catch me on it. C, yes or no? No. Questions so far. What we've done is the vocabulary. You need to know what is a geometric sequence, what is converging, diverging, and how to find r.
Okay, so B in R is, like, it's not negative 2?
It is not negative 2, because if you take any term and divide by the previous, what's negative 1 divide by 2? Right, you need to have a diverging sequence to get negative 2. Sorry?
I'm trying to find a pattern. So like for A, I'm trying to understand. You divide 27 by 9. Then
Correct.
9 by 3.
Correct.
And then 3 by 1.
Correct.
And if they're all the same.
Correct.
Okay. And if it's going up, it's divergent.
Correct. Other questions? And if you're not sure on something, that stop me and ask, because you want to clarify it in your head before we go on. Let's get into the more kind of examples you're going to see in the homework. Now, heads up, this is how I do the note package. So first thing I do is I read through I've read your whole textbook cover to cover, your whole workbook. So I read through the examples and I check off which ones do I like, which ones do I don't like. That's where I start. Then what I do is I look at the homework assignments and I think, okay, what are the most important questions I need them to do? And I circle those questions. Then what I do is I start looking at the examples. So the first couple homework questions will always be example 1 or 2. So there's a heads up. If you're starting the homework at the beginning, it's probably 1 or 2. Those are what I call the straightforward ones. They're kind of the standard, just find, no tricks, no application. Then I look at the homework again, and I'm like, ooh, there's a question that's a little bit different. So I write an example to go with it. Then I come to another homework question. I'm like, ooh, that also is different. I write an example to go with it. That's why it's really important you're always checking back the examples when you're going through the homework, because they're going to correspond. So if you're at the beginning of the homework assignment, it's probably examples 1 and 2. If you're in the middle, it's the middle examples. If you're at the end, it's probably near the end. That's how I do examples. So I go the questions first to make sure you have an example to go with every question. Does that make sense?
When you started the common notes,
Mhm.
the first thing you wrote down,
Mhm.
is it pause? It's plus?
No, thank you for stopping me.
Sorry,
No, that's why you stopped me, because I make mistakes too. Fix that if you didn't catch that. I said multiplying, but then I wrote plus.
You were writing sideways, so
Oh, is that what I did? There you go. There you go. I could very well could have. You have to remember, I teach 4 different math classes a day, so sometimes I have grade 9 in my head because they're right before you. So fix that. Thanks for stopping and catching that. This is where we're going to the paper, because this is example number 1. You already have your title. This is a straight up find a term kind of question. So they want term 7, they tell you T1, and they tell you R. Straight up standard kind of question. Question is asking for T7. T1 they've given us straight up is 384. R they've told us is a half. And just like before, ooh, drop my highlighter. The n on the left-hand side is exactly the same as the n on the right-hand side. So what you put it on the left, you put it on the right. So 7 minus 1. I do the subtraction first, and I actually do it in my head. Rarely do I write down 7 minus 1. I jump straight to 6. This now becomes a calculator question, so grab your calculator. And the thing I really like, well, there's a few things I really like about your calculator, is that you type things pretty much the way that you see them. So it's not like you have to worry what goes front, what goes back, like regular scientific. This is straight up what you see. So you're going to type 384. You're going to open a bracket. You're going to do 1 divided by 2. You're going to close a bracket. What's the exponent key? It's called the hat or the caret. Where is it? Right above on the left-hand side, above the, on the right-hand side for you, right-hand side. It's called a hat or a caret if you're in computer science. And then you type 6. Really? Ask Mr. Rox about that. Yeah, call it a caret. I'm going to repeat. You're typing 384, open bracket, 1 divided by 2, close bracket, the caret symbol, and then 6, and then you're hitting enter. Like 6, just 6. 6, there you go.
what's the whole hat again?
It's called a caret. It's the exponent key on your calculator.
Okay. Is it legitimately called a
Yeah.
carrot? How's it spelled?
C-A-R-O-T. No, because there's carrot with a K, like gold carrot. It's with a K. No, you know. Questions so far? Example number 2. Again, a straight up question, just asking for a particular term. Question wants T10. T1 is 2. R is so take any term, divide by the previous term. So 8 divided by -4, -2. N minus 1 would be 9. Grab your calc, type in 2, open bracket, -2, close bracket, caret 9 or hat 9. Did they tell you last year the difference between the negative and the subtract key?
Yeah.
You talked about this before. So negative key is where? At the bottom. And you'll know because when you type it in, it's higher and shorter. Subtraction key is longer and lower down. And if you get them wrong, you'll get an error. And if you pick go to, it flashes on it. It's pretty smart. Uh, 10.4? 1,024. Did I hear that correctly? That sounds confirmed already? So these are the straight up, use the formula, put it into your calculator kind of questions. These will be the beginning questions in the homework. 3, we're going to change it up a little bit. I want you to circle or highlight the word create. What does create mean mathematically? Find, I like that. Give me another synonym. What does create mean mathematically? Make. It means make up your own example. That's what create means. Make up an example that has these conditions. So the question is telling you the fifth term is 48. That's all you get. So we need blank, 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 48. The nice thing about create questions is there typically isn't one correct answer. There could be a bajillion answers depending on what your brain does. What you want to do is pick a number that divides into 48. You could pick 2. You could pick 4. You could pick 6. Give me some other numbers you could pick. 48. You could pick 24. You could pick 12. You could pick 3. Pick any number you want. I'm going to pick 2 because 2 is a nice number to divide by. So if I'm going to pick r equal to 2, what's the previous term to 48? What's the previous term to 48 or to 24? What's the previous term to 12? And what's the previous term? There's creating a geometric sequence that has those properties. Let's say the question says, because sometimes they'll be tricky, they'll be like, create 2 examples that have these properties. Pick something other than 2. 3. 12. Which one do you want to pick? Let's do 12 just for crazy time. 48, r is 12. How do we go to the previous term? Divide it. Now the silence comes. 48 divide by 12. Okay, divide by 12. So we're going to have 48 divide by 12, and then we would reduce it. 1/3. Then we would have 1/3 divide by 12. Oh, I love it. So let's do division over here. Let's quick little review of how to divide fractions. What's under the 12 that we don't see, but we know it's there? The 1. Yeah, what's the mathematical word for flip it? What do mathematicians say? Starts with an R. Might rhyme with reciprocal. Reciprocal. So we're going to flip the 12 over 1 and make it 1 over 12. And then what do we do? Top times top and bottom times bottom. 1 over 36. Ooh, and now we get to do 1 over 36 divided by 12. I love it. Where are we confused?
Is that 1 over 3 over 12? No, not that one. No, left. Yeah.
Yes. 1/3 divided by 12.
Thirds in brackets.
Okay. Does it matter? Mathematically, does it matter? Yeah, I would too. But let's just say we picked 12. Because it was fun. It was fun for me. Yeah. Do you understand what the word create means? So because I've chosen this example, it tells you there's probably going to be a homework question that says create. So when you get to that question and you're stuck, what are you going to do? Pull out this example. Mm-hmm.
What are we dividing? We're dividing by 12?
Yes. Because you picked it. No calculator. No. Why not? We don't need a calculator for that. Questions so far?
Would we lose marks if we did 48 times 1 and then just all of the terms were 48?
The problem is the way we've defined r is we have r as greater than 1 and we have less than 1. We have not defined r as 1. So by definition, a geometric sequence can't have an r equal to 1. Did I just foil your evil plan there? Let me know when you're ready to move on to 4. James, are you tactile? Really, that's so tactile. Let me know when you're ready.
Doesn't have graphics on. I'm ready.
Everyone else? T1 is 5. T5 is 1280. What is T2 and what is T6? Well, I have T1, so it's pretty easy to find T2 if I have what? R. So this is a finding R question. Any question in the homework where you need to find R is going to work exactly like this one. Going to use the Tn formula. Just waiting for Anthony because he's not quite ready. I'm going to put the value of T5 on the left-hand side. I'm going to put T1 as 5. R I don't know. And if I put T5 here, then this will be 5 minus 1. First thing I'm going to do is just that subtraction. So 5 minus 1 is 4. How do I get rid of the coefficient of 5? Divide by 5. Sorry? But we're solving equations, so it's opposite BEDMAS. 1280 divided by 5. 256, I heard someone offer. You can't confirm your own answer. Questions so far? Last thing I need to do is get rid of an exponent of 4. What's the opposite of an exponent of 2, for example? How do we get rid of an exponent of 2? When something is squared, how do we get rid of it? We square root. So what do you think we're going to do with an exponent of 4? We're going to fourth root it. How the heck do you do a fourth root on your calculator? You go 4 first, then math, then in the math menu? Yes, so if we're in the math menu. Number 5. And then you put the 256. I'm here and offer a 4. Confirm 4. Make sure you know how to do a fourth root or any kind of higher root on your calculator. Now you have. Okay, question asked for T2 and T6. How can we find T2? How can we find T2? We got T1, which is 5, and we're going to times by R, which is? So T2 has to be? That was not a trick question, 20. How do we find T6? Take T5, which is 1280, times by R, which is 4. Say the first part again. 5,000. Offer of 5120. Confirm. Okay, so any example in the homework where you need to find R, it's going to work exactly like this. It's just going to be different numbers. What about part B? What is the question asking? I want you to highlight or circle how many terms. We've done 3 examples now where we have found how many terms. What is that asking for? N. So this is a finding N question. So any question in the homework where you need to find N is going to work exactly like this one. Tn equals T1 times r to the n minus 1. The last term they've told us is 20,480. The first term from the previous part of the question is 5. R is 4. We just found it in part A. N minus 1 we don't know. How do we get rid of a multiplication by 5? $1,096 is the offer. Oh, sorry, $4,096. Confirm. Questions so far? The next step is a little bit of guess and check, just a little bit. What I want to know is 4 to the what equals 4,096. So let's use some logic first. It's not 4 to the 1, because what's 4 to the 1? It's not 4 to the 2, because we know that one is. So you got to go a little bit higher. So what you're doing on your calc is 4 to the what equals 4,096. So let's try 5. Where did I get that? I picked it out of the blue. So on your calculator, do 4 hat 5. Are we too high or too low? Too low. Okay, so let's go up one. Let's try 6. 4 to the 6. Okay, so everyone okay where we're coming from 4 to the 6? So I'm just going to put 4 to the 6 then on the left because I know that's exactly the same as 4,096. Questions on that step?
Is there a mathematical way to get that? Or
Yes, but you won't learn it till grade 12. It's fun, but it's an entire unit that takes a whole bunch of theory before you get to where you need to go. That's why in this we're just using some guess and check. Okay, if 4 to the 6 equals 4 to the n minus 1, logically it means that 6 has to equal n minus 1. So what we get to do is just drop the bases. I know that the exponents have to be exactly the same. The reason I know that, because I can't have a 4 to the 6 equal to a 4 to the 8. That doesn't make sense. I can't have a 4 to the 6 equal to a 4 to the 9. A 4 to the 6 has to equal a 4 to the 6. So therefore, if 6 equals n minus 1, what is n? Anytime you have to find the number of terms, it's going to work exactly like this one. The numbers are just going to be different. Questions so far?
So to answer that question, just write T7.
Yep, 7 terms. This one's out. How many terms are in the sequence? 7. How do you get rid of a minus 1? Mathematically, if the bases are the same, because a 4 to the 6 has to equal a 4 to the 6, so we know 6 has to equal n minus 1. Insert 4 terms between 81 and 1 over 729, ooh, don't like that number, in order to create a geometric sequence. So this question is really giving you the first term. It's telling you there's 4 terms in between, and it's telling you the 6th term is this nasty number. Question just wants you to fill in the blanks. Well, if we have T1, what do we need in order to calculate T2? R. So this is another finding R question. So you might just want to look back at number 4A, kind of put those steps back in your head because it's still finding R. Okay, so step 1, we start with the formula. I'm going to put the value of the last term on the left-hand side. I'm going to put T1 as 81. R I don't know. And I need to find n. Well, we just count what term is 1 over 729. It's the 6, so n has to be 6. Okay, peek back at 4A. What did we do in the first step after we filled in the formula? What did we do next? We did that 5 minus 1, so what's the same step here? 6 minus 1, which is going to give us 5. Okay, then we divided by 5 in the last example, so we're going to divide by 81. Oh, got that nasty fraction stuff again. It's okay, we're not going to panic. What's under the 81 that we don't see but we know is there? What do we do to the second fraction or the bottom fraction? We flip it, and the mathematical word for that is reciprocal. And then we just do the top times top and the bottom times bottom, so 1 times 1, no biggie. Bottom would probably be a calc question. 81 times 729, going to be a big number. 59,049. Can someone confirm? Okay, what did we do in the example 4a when we were at this step? We fourth rooted it, so what do you think we're going to do here? Fifth root. I'm going to do something a little bit different on the left. There's an exponent law says that when I have a fraction, I can apply an exponent or a root to the pieces. So what I'm going to do is just fifth root them individually. So rather than doing the whole fraction, I'm just going to make it a little easier on our calculator. And the top is easy. What's the fifth root of 1? What times what times what times what times what equals 1? 1. So all I need to put into the calc is really just the fifth root of 59,049. Oh, no 5 there. But I'm dealing with a fraction. That's why I just put the bottom in. Confirm the bottom was 9. So 1/9. Do you see similar to 4a? Right, so that's what you're going to do when you get to your homework question is you're going to find the one that looks like the example and follow it. Now, Aiden, why did you shake your head? Why does it not look similar to your brain? Okay, are you with me what we did in 4a? Okay, but now are you with me in 4a? Four, 6.
Like 4 to the power of 6. That was...
I'm on example 4 and you're on example 5. Or you're on example B. I'm on 4a.
Oh, okay. Yeah, I'm okay on that one.
Okay, do you see how this one's exactly the same, just different numbers? Okay. Everyone else is okay so far? How do we get the 6 minus 1? Because n is the sixth term. 1, 2, 3, 4, 5, 6. It's a sixth term in the sequence. We're not done. We got to find T2. Well, if r is 1/9, how do we get T2? So 81 times a ninth, 9. 9 times a ninth. 1 times a ninth. A ninth times a ninth. 1/81th. Questions so far? Number 6. Remember, as we get later in the examples, they get harder because that's the same as your homework question. So there's obviously one like this in the homework. If 9, x minus 1, 1 form a geometric sequence, find the values of x. Highlight that s in brackets on values. Rarely do we put that imaginary little s unless there's more than 1. So when you see that on a test, it's kind of an indication you should have more than one answer. If there was only one answer, we would just say find the value. So it's like a little hint there's going to be 2 answers. So we got 9, we got x minus 1, we got 1. Well, in order to find x, I need to know what T2 is. In order to know what T2 is, I need to know what R is. So this is another finding R question. That's going to be step 1. So take back, where was the look back? Where's the one we did finding R? Number 4a and number 5a. So this is now the third time we're going to find R. Yes? Thank you. What's the last term in the sequence? 1. What's the first term in the sequence? Not a trick question. 9. What's R? We don't know. What is N? So the 1, what was its term number? 3. You should be now starting to see a pattern between 4a and 5a, and now this one, what are we going to do next? The 3 minus 1, which gives us 2. Next step. The next step. And with a fraction, I'm going to square root the pieces just because it's a little bit easier. Now wait, grab your red pens. There was something you learned last semester or last year when you took grade 10 math. Every time you take a square root in an equation, what do you have to put in front of it? A plus or minus. What? Why? What is going on? Okay, what's 3 times 3? 9. What's negative 3 times negative 3? So what's the square root of 9? It's either 3 or negative 3. We don't know. That's why you need to put this in front. So that tells us that R is plus or minus. The square root of 1 is 1. And the square root of 9 is 3. What that gives us is 2 different R values. The first one is positive 1/3, and the second is negative 1/3. That is going to be your reality every time you take a square root. You have to put that plus or minus in front. I'm going to repeat. It's because 3 times 3 is 9, and negative 3 times negative 3 is 9. So the square root of 9, we don't know if it was 3 or negative 3. This is where that values is going to come from, is because now we have 2 different R values. So I'm just going to split here. I'm going to use the first R value, then I'll use the second R value. So we had 9, and then we have something. If the first R value is positive 1/3, what's that second term? It would be 3. Agree? Well, 3 now we know is x minus 1, because they told us the second 2 was x minus 1. What does x have to equal? 4. Waiting because I'm hearing some question marks. Ask questions if you have question marks. Okay, I'm going to do the same thing over here. 9 then something. This time I'm just going to use that negative 1/3. So what's the middle term if the R value is negative 1/3? Negative 3. And we know that negative 3 is x minus 1. What does x equal? Negative 2. There's why it says state the values of x. There's 2 of them because there's 2 R values. Questions? Please know that when we're doing examples, I don't expect you to now understand this 100%. It's like hearing a new piece of music or seeing a new play in a sport. You got to practice it in order to understand it completely. When does the practice part come? I would like to wait and do example 7 next day because I think your brains are a little bit full. Yes. Homework is on the calendar. You have time to do your scariest one.